Ken Forrester, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 231 of our Momenta Industrial Impact podcast. Today I'm pleased to host Kence Anderson, CEO and co-founder of Composabl, the platform for building industrial strength, intelligent, and autonomous agents. Momenta just led the seed round for Composabl, our 53rd portfolio company. Kence is an entrepreneur and innovator in the field of autonomous systems. He has designed over 200 intelligent autonomous agents for companies such as PepsiCo, British Petroleum, Shell, ABInbev, Bayer, and others. Prior to co-founding Composabl, Kence was director, autonomous AI adoption for autonomous systems at Microsoft, having joined them as part of the acquisition of Bonsai. He also recently authored Designing Autonomous AI, a guide for machine teaching, published by O'Reilly. Kence is himself the son of a master teacher and is trained in mechanical engineering, and he utilizes both aspects by researching how the principles of teaching, combined with human expertise, can be used to design and build useful AI. So Kence, welcome to our Industrial Impact podcast.
Thanks, Ken, for having me.
And thank you for taking the time to do this. And great, because right at the front of our announcement for investing in Composabl, which we're very proud of. So you likely know we used to call this the Digital Thread podcast and recently really focused this on the industrial impact side. But I still like to ask kind of the signature question, that is, what would you consider to be your digital thread? In other words, the defining interests and experiences that brought you to this key point in life.
That is a really great question. I love the idea of the thread. My background is in mechanical engineering. So, I grew up as a kid loving, jets and planes and trains and things like that, things that move. But ironically, I started my career at IBM and databases and spent my whole career in software. Composabl is the 8th startup that I've been a part of, my second time out as a founder. And the first 5 of those startups that I worked for were in the ad tech and marketing tech area, which was interesting to me because, one, I just got to see how Silicon Valley operators operate, and I got to see what it was like to be at a company, Silicon Valley companies that were acquired. I think there was 4 of them. But also, ad tech was really the first enterprise application of machine learning. So that's how I kind of cut my teeth on machine learning. And my first time out as a founder was a company called Optimize, and we did actually agents, financial simulations and agents for real-time trading on the programmatic advertising market. But the thread for the last 7 years really has been about industrial autonomy. And I was thrilled to join Bonsai in 2017 because I felt like it was coming back to my roots. It was 2 things that are really core to me that you mentioned in the introduction. One is Bonsai was focused on how to apply AI to industrial systems. And that's where I come from as a mechanical engineer, machines and manufacturing processes and logistics, decision-making, things like that. And also this idea of machine teaching. And, my father was a teacher, and I've considered being a teacher multiple times. I'd say that's actually my superpower, is as a teacher. And I was fascinated with this idea that if machines can learn, i.e. machine learning, then we should be teaching them something. We shouldn't be just plugging them in and, seeing what they learn and hoping for the best. That's not what we do with people. That's not what we do with the greatest general intelligence out there, the mighty human brain. We teach it something. And so I was actually the person out traveling the world in 2017, 18, 19, part of 20, going to all sorts of places, every kind of factory, oil refinery, mine, warehouse, logistics center, and talking to executives all the way down to operators, chemical plants, to help understand and figure out how to apply AI to industrial decision-making. And really, my book is just kind of the methodology that I compiled along the way about how to design these kind of systems.
And we'll talk about the book in a minute because I thought it was very well done. And actually, really good for the novice in this space, which is not truly where you think about O'Reilly. I joke with people that the typical O'Reilly book is you hit assembly code in page 3, right? This one truly is, as you say, a novel, and one might even say a manifesto for the use of autonomous AI in industrial. So I have readily recommended this at every point. I'm glad you mentioned the background in ad tech, because I did notice that, and certainly the first startup you did in terms of Optimize. You mentioned just a moment ago, what attracted you to Bonsai. And I'm really curious because you joined Microsoft when they acquired Bonsai in 2018 and worked your way across their AI and research teams before leading autonomous AI adoption. I'm really curious, what did you learn working at Microsoft, and truly of what are you most proud?
That is a great question also. Microsoft really is a platform company. I learned two things about platforms that I think about partnerships. First, the platforms. In all 8 startups that I've been a part of, they were all B2B platforms. So I've never worked for a B2C company, never done kind of like a vertical solution. And so I have lots of, affinity for horizontal platforms that are really able to tackle a market effectively. And that's Microsoft's bread and butter. That's what they do. Developer evangelism, building an ecosystem around platforms, building huge businesses out of platforms. I learned so much from executives and individual contributors and scientists at Microsoft in regards to what it means to build and market a successful platform. And the second thing is Microsoft really is about partnerships. Even things that quote unquote seem competitive, like building Linux into Windows. And there's just so many things that they do that show that they're really about OpenAI, is a perfect example. But long before OpenAI, they were demonstrating how partnerships can help you attack markets. It was really fun place to be for 5 years.
I had to laugh a little bit at your comment around developer relations. We have one other company, very specifically in AI, where the founder came from a developer relationships background. Of course, that's the company's Edge Impulse. The founder is Zach Shelby, who was head of developer relations at ARM. And we've had such good luck with founders who have that background in terms of building up, if you will, the ecosystem, that we've now begun to look for founders who have a developer relations background. So I'm glad that you mentioned that and your own background as such. So you co-founded Composabl in actually April of 2023. So as we're recording this, you could say roughly a year ago, together with Javier Geering, your CTO. What inspired both of you to start Composabl?
So it really is this idea of a methodology, for machine teaching. And I have this hypothesis that any nascent, complex, high value technology is likely best adopted through a methodology. And there's lots of examples. You can even go back to your background, Ken, in industrial control systems. Ladder logic is the methodology for programming and building PLC systems for industrial automation. Excel formulas. Back in the 70s, in my first job, I certainly wasn't around there in my career, but my first job out of college was working at IBM DB2. That's the first relational database. And relational algebra was the methodology that helped people understand how to ask questions of databases. Before that, you had to write very complex computer code just to ask a database a question. And now with things like Excel formulas and a platform, you kind of methodology plus platform abstraction equals, mass adoption or democratization. One of the latest examples is, prompt engineering. Prompt engineering is the methodology for how to work with or how to get results, whether it's images or text, out of a large language model. And so you could think of machine teaching as prompt engineering for intelligent autonomous agents. So if you're trying to build these intelligent autonomous agents that can control machines and factories, that can control entire manufacturing lines and processes, can make logistics decisions, it's actually machine teaching is that methodology. So Composabl, and the reason we called it Composabl is because the methodology teaches you how to break down complex tasks into skills. And I don't think that's machine teaching. I think that's teaching. That's what teaching does is take complex things, whether it's chess or football or Go or basketball, jazz music, all of those things get broken down into smaller component pieces by expert teachers and then given to students or learners to practice. And usually the practice is sequenced. That's what a basketball practice is or a chess coaching session is. And then you master each of the skills by practicing, and then you combine the skills together. And so Composabl provides building blocks for engineers to be able to build these agents from composite skills, which might be algorithms or might be heuristics. It might be models, AI models, computer vision models, or even things like large language models. There wasn't anything out there, including Bonsai, which was a fantastic platform, but there wasn't anything out there that really reflected what I had experienced in the effectiveness of this methodology. And so Composabl is the best representation that we could come up with of, or a reflection of this methodology and how to build software that helps people teach machines.
I think it's one of the areas that really appealed to us in some of the early conversations. We were considering an investment. For anybody who's been in a manufacturing environment, factory floor, control systems engineers, et cetera, some of the newer, I'll call it advanced optimization technologies, and including a lot of AI, traditionally require some form of data scientists to operate, or data engineering. You hear a lot more relative to factory floors. And I think what really appealed to us is the fact that what you're attempting to do is go right to the people who know the domain rules better than anybody else, i.e., the people on the factory floor, and being able to train them to train these autonomous AI agents, and thus skipping kind of the, I'll call it IT-ish data science aspect of it in terms of capturing these rules and everything else. And your book does a really good job of describing how one would traditionally train these systems and how you're able to do it with your methodology now. Now, you just described it as a kind of a manifestation of the methodology, but you guys also described Composabl as a platform for building industrial strength, intelligent and autonomous agents. I'm going to ask you to put on your master teacher hat and treat us all as laypersons, because that's what we are. So in a layperson's terms, what does that mean?
Yes. So imagine you're flying a drone, right? So I'll give you a couple of examples of drone flying that represent two potential ways that you could design an agent. First of all, there's completely different skills in flying the drone. Takeoff and landing are two very, very, very different things. Avoiding obstacles as you're flying around, or how to get from point to point when your battery is running low. Those are all very, very, very separate skills. And any learner, whether it's a machine or whether it's a person, gets confused if you try to learn all the skills at once. You're trying to learn takeoff and landing and avoiding obstacles all at the same time. It's going to take a really, really long time to learn, and you're going to develop bad habits. And so a teacher breaks those skills down and practices them separately. And in fact, constructs scenarios where you want to practice them separately. For example, in the windy scenario, you need to practice landing. But in a super windy scenario, you might not have to practice takeoff for a plane or a drone because you're not going to be allowed to, or you shouldn't. It's too windy. But if it becomes windy while you're flying, well, you're stuck up there. You have to learn how to land in windy scenarios. You have to learn how to avoid different types of obstacles. So in the practice, you're going to be subjected to different scenarios. So in Composabl, you can easily create each of these skills. Okay, I want to create a landing skill, a takeoff skill, an avoiding obstacle skill. Okay. And then you can use a no-code interface to kind of drag and drop these things to arrange them, because sometimes skills are orchestrated in sequences. Obviously, takeoff happens before landing in all cases. But sometimes the skills are organized in more of a hierarchy. And in fact, most of the drones that folks use you're not actually directly controlling the rotors. That's usually kind of cheaper drones. My son used to have one that was very hard to control because it's very difficult to control all four of those rotors directly. And so usually, in the same way as there is in a factory control system, there's an abstraction layer. There's a PID controller that's actually executing, and you're basically telling the drone which direction you want to go, and what should the pitch, yaw, and roll be, or this is where I want to go. And then the PID controller underneath is actually moving the four rotors to get you there. That's a pattern I call the plan execute pattern. So I've already given a couple of different design patterns that show you how you could teach skills. You could teach skills as plan execute, tell us what to do and where to go, and then figure out how to control the drone, how to get there. Or you could do it with strategies or skill sequences, take off first, then fly and avoid obstacles, and then land.
What have been some of your early wins now at Composabl?
So my first test for Composabl was handing our Python SDK to for creating intelligent agents to a few system integrators, folks like Rovasys, who's industrial automation system integrator, Wood or Wood Group, Decision Lab, others. And because I knew that they could tell very, very, very quickly whether you were able to build the kind of agents that they knew were performing and we were really ready for prime time or not. So we signed 5 system integrator partners that are out reselling the platform and using the platform. I was actually out at Rovasys last week, and we did a hackathon and we did a lunch and learn. It's really, really fun to work with engineers. I mean, these folks there's a few computer scientists there, but mostly mechanical engineers, industrial engineers, systems engineers, and teaching them how to do this. And it's very intuitive for them. Engineers are used to building blocks. If you give them the right tools, they're going to do this very well. We have 2 Fortune 500 companies that are currently building agents to control high value processes. One of them is making a process autonomous for the very first time. It's a process that takes over 10 years to learn how to do very well. And so we're really proud of what our customers are doing with the platform.
That's great. Wow, you guys have accomplished quite a bit in a year. Another reason that we were excited to be investing behind you. So perhaps this question is really focused on those process engineers and control system engineers and really wanting to learn the space. So how do new clients engage Composabl to solve industrial AI challenges?
Yes. So one thing that I really am proud of and happy about is seeing people interact with the methodology. So when we launched our beta last August, I started making the rounds and calling up folks. And there was both a major chemical company and one of the largest CPG companies on earth. And in both cases, I asked them, do we know each other? How'd you get into the beta? And they both said, oh, well, you don't know me, but I know you. I read your book. And, there were multiple folks at system integrators and others that said, oh, I took your course. I have 2 courses on Coursera, and actually I teach 2 courses for A3, the Association for Advancing Automation. And folks take the courses, get interested in the methodology. In fact, there's a mechanical engineer who runs a kind of a industrial engineering SI practice. His name is Andy Lonizak, and he told me after a course he took with me, he said, I thought I was going to have to go get a PhD or a master's degree in AI in order to get involved. And I felt very left out of the process. And I took your course on AI for industrial automation, and I realized I can get involved now. I love that kind of thing. And that is actually a big part of how our pipeline gets built. The second way is really our system integrators. They're out there working with all the top tier chemical companies and oil and gas companies and mining companies and CPG companies, et cetera, et cetera. And we really feel that if we can empower them, then they'll empower us in the marketplace.
So it's very much going back to your concepts earlier, developer relations. In this case, you could say engineer relations and an ecosystem that's built there. What I appreciated about your book was, since I'm a former control system engineer, PNIDs, or I'd say when you look at PID loops back then, trying to program those was, required quite a bit of skill back in the day, at least a good understanding of the math that went behind it. And yet you drew analogies real early as a basis for how you move to more advanced optimization. And I appreciated that, having looked at the book, it felt like it was written for me, or at least somebody who had my kind of training. So you're certainly making it relevant in that regard. I've got maybe a bit of a more contextual question for you, and that is, Momenta has been investing in industrial optimization and AI for now over a decade. But, it's interesting. We've noted that few of these systems, at least up until recently, have been used in autonomous, aka, kind of closing the loop, if you will, applications. What are you seeing as the key motivations for many companies now finally considering this?
That is a beautiful question. So, first of all, there's a narrative which has some truth to it, but I'm going to call it a false narrative that says to industrial companies, the first thing you've got to do to achieve digital transformation is go, implement these new IoT systems to store all your data. And then you can start analyzing the data and creating some insights. And then maybe you can start building predictive models and making predictions and perceiving things. Of course, you're going to need, many, many data scientists, which are not really part of your organization. And then maybe you'll be able to optimize something or make a real-time decision. That is a false narrative for industrials in a couple of different ways. First of all, historians have been collecting and tracking industrial data and factories for decades. So it is not true that without some new IoT system, you're not going to have any data to analyze. Now, certainly, things like cameras and microphones and new kinds of sensors and IoT platforms and data platforms that consolidate data in one place. There's certainly lots of legacy systems where data is siloed. So all that's true. But the narrative that you need to start fresh because you don't really are tracking anything is false. And then the worst part of the narrative, though, is that sometime later, after you get very, very advanced, you'll be able to control things. Like the PID controller was invented in 1912 by the US Navy. So every factory has control systems in it, period. There's not a single factory without a closed loop control system in it. So what I found when I first started back in 2017, really making the rounds and talking to folks was engineers don't actually care about the acronyms, ML, AI, DRL, whatever. They see each new technology as a potential new tool in the toolbox. And so unlike AI research, which tends to have a one-track mind and say, like in the 80s, expert systems are all of AI. And actually, in the 80s, the public opinion about expert systems was the same as we currently have about generative AI. It's going to replace doctors. An expert system will maybe become conscious someday. Like it's in the press recordings. You can see it. And then, of course, the same thing was true for neural networks and supervised learning and deep reinforcement learning, this AI that learns by practicing, that mastered the game of Go and beat the best Go player in the world, and now generative AI. Engineers don't have a one-track mind like that. Engineers have hammers and wrenches and screwdrivers, and you need all of them. It's not like when the wrench was invented, you didn't need a hammer anymore. I mean, there's still nails and there's still screws. So really, it's about different decision-making characteristics. So if you take an expert system, which we were talking about earlier, an expert system is fantastic at capturing existing expertise. It can be a pain in the neck to maintain all the rules and keep the rules updated, and it can be very rigid. It certainly doesn't learn on its own. But for example, safety critical procedures, it might be the best way to make a decision. A control system that uses basically math to make its decisions, it is deterministic, it's predictable, it's the absolute best thing at low-level control, which is what PIDs typically do in factories. But if you don't have the math to describe the complex and nuanced situations, which you often don't, especially in chemical processes, then it's not going to make the best decisions, and so on and so forth. So it's not actually about what's the best algorithm and the new algorithm to rule all algorithms. It's actually about how you combine the right tools and in the right ways.
Man, you had so many great points in there. I love the one about PID loops really being closed loop control, which is absolutely true. We've taken to calling this whole space just optimization, industrial optimization. And of course, given all of the hype these days around generative AI, kind of the reawakening of AI in some sense, we've certainly tried to tag on to that term. I was at the Hanover Mess last week, and Edge Impulse had a booth there, and we did a tour bringing a bunch of B of A analysts through. And they described themselves, Edge Impulse, as they were presenting, as real AI versus generative, just to set the stage right off the bat. We're not going to talk LLMs here, right?
I used to use the term useful AI a lot.
I like that. Actually, I like that. If there was a common theme last week at the show, it was, I'll call it certainly generative AI, but optimization, right? People were talking about various forms of AI, and one of the drivers for it is just your labor, right? Right now, especially knowledgeable people who understand the domain rules are, obviously leaving many times with institutional knowledge as that whole workforce begins to retire. And the younger generation isn't necessarily coming in. So in some sense, you have to capture that knowledge, and you have to be able to capture the skills that go with that as well. And I think that's what makes what you do so beautiful, because you're helping to train a whole new generation. You're helping to train, if you will, the older generation that's going out, and you're codifying that into intelligent agents, right?
This is my favorite aspect, actually, of intelligent autonomous agents. I mean, the word autonomy tends to suggest, that it's doing something on its own, and people think of people being replaced. But, out of those 200 agents I've designed, 65, 70% of them were intended specifically to help less experienced operators do a better job, or give the expert operator the time back to go do something else that they need to be doing. Digital transformation, which I think we're 10 or 15 years in, you'd be better to tell me this than I would be to tell you as far as how long digital transformation has been happening. But it's foundational, surely, but it's mostly about storing data and documents. And you don't transform or revolutionize an industrial business by storing data and documents. That may be a controversial statement, but if you think of it in the context of industry runs on these crucial high value skills, Max Petrie, who used to run R&D snack food division for PepsiCo. PepsiCo makes, Cheetos and Doritos, Fritos, and a bunch of yummy stuff. And I asked him, what's the most important part of your business? He said, the most important aspect of our business is the skills of our operators. And even before the Great Resignation, those folks were retiring. I mean, I've worked with processes where folks said when the expert gets sick or is on vacation, the throughput on a particular line or system goes down by 40%. Folks are getting called out of retirement just to come in for a few days and solve rare scenarios that haven't come up in a while. And so intelligent autonomous agents are the first opportunity that I ever know about to store these high value skills. And it's not to replace folks, it's to preserve these skills. So imagine you've got a database of your 10 or 50 most high value skills that you can use as a colleague or a coworker or a co-pilot or whatever you want to say, however you want to say it, to your experts and your novices. And you've got a training program for your less experienced operators.
We often talk about automation to autonomy, to leverage a term that I think the CTO at Rockwell coined. And what we have seen in that spectrum going from automation to truly autonomous operations is that augmentation ends up being a middle state, right? Exactly what you're saying, where you're helping operators, you're helping maintenance people, et cetera, to better operate the process as you're moving to closing more and more loop, if you will, control over time. So I'm glad you brought that point up. I promise everybody, this is my last pitch for Kence's book, but Designing Autonomous AI, A Guide for Machine Teaching, again, an O'Reilly book. So I would certainly recommend this as a primer on industrial AI, but you mentioned some other resources a moment ago, including your Coursera work. What would you recommend to potential clients, users, and people who really want to learn about the adoption of optimization, if you will, or useful AI, to use your point, in industrial?
Yeah, I think the book is certainly a commitment, but hopefully I've made it an easier and enjoyable read. The courses can be a great place to start, especially the Coursera courses, because you can take them in bite-sized chunks, and they're video-based, and I think each course has 20 or so videos, and you can take things at your own pace. In the future, I will be writing more things that are even smaller and more bite-sized, whether it's white papers and articles and things like that. But there's a lot of work to be done as far as machine teaching. That's the fun but challenging part of evangelizing a methodology. Is it's a teaching exercise. Not to make a pun with machine teaching, it is actually a teaching exercise where we have to teach the methodology. Now, the good news is, and this is another thing I learned at Microsoft, where I was talking to someone about this framework that's called the Cloud Adoption Framework, which was actually invented, as I understand it, by AWS, which would make sense since they, invented infrastructure as a service cloud computing as we know it. And this person at Microsoft explained to me that if your methodology is successful enough, it actually disappears because it kind of becomes the fabric of how things are done. Because I remember asking him, well, why do I never hear about the Cloud Adoption Framework? Because it's just how people use the cloud. And if we're successful, which is going to take a lot more work and a lot more passionate evangelism, then machine teaching will be the way that folks design industrial control systems in the future.
Well said. So in closing, I always like to also ask, I'm kind of curious about how you maintain your edge as a leader. Any recommendations you would like to highlight for the listeners?
I'll just highlight one. Because of my background, which is often being a minority, which isn't just a racial minority, but certainly it was in my childhood, being a very technical person among salespeople and being a very salesy person among technical people, there's all sorts of situations where I've been in a minority. It makes you come at things from different perspectives. There was a Nobel Prize winner in chemistry who was asked, a Japanese professor who was asked, what's your secret to innovation? And he said, coming at a problem from multiple different disciplines. He said, you have to understand multiple different disciplines, and where they intersect and come together is where innovation happens. And that's one of my personal secrets is you come at it from a teaching perspective, you come at it from a programming perspective, you come at it from a engineering and industrial controls perspective, and you can come up with some innovative perspectives.
Absolutely. And I've heard people describe it as pattern matching, right? Look
Exactly.
across these different disciplines to match patterns between all of those. And that really describes, I would say, your average target controller process engineer, because you have to master a lot of different domains and disciplines to ultimately run and optimize a manufacturing process. And again, I promise, but I have to do it one more time. The book does a really good job of capturing that kind of multifaceted, if you will, aspect of that. So look, Kence, thank you very much for taking this time and sharing these insights with us today.
Of course. Thanks for having me, Ken. It's great to be part of your portfolio.
And it's great to have you there. And this is only the beginning of how we begin to promote you. So we're going to be very excited as we make the announcements coming up. So again, this has been Kence Anderson, CEO and co-founder of Composabl. Thank you for listening. And please join us for the next episode of our Industrial Impact Podcast. We wish you an impactful day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archive versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.